In this lesson, I'm going to be going through the proof of the product rule. We have been doing examples with the product rule, and you probably know how to use it by now, but it is important that you get exposed to proofs and why these rules exist. So in order to do this proof, I am going to set it up in a very similar way to the last proof. So I am going to start off by saying, let p of x equal my original function f of x times g of x. Then I'm going to go ahead and start using my first principles, and I'm going to be saying p prime of x is equal to the limit as h approaches 0 of p of x plus h minus p of x, all divided by h. Now I can go ahead and I can start plugging in what I know. So the limit is h approaches 0 of f of x plus h times g of x plus h minus f of x g of x, all divided by h. Keeping my end goal in sight, so remembering that my goal is to eventually get this, I can already see that I don't have enough information in this. I don't have enough expressions in here to get to that goal. So what I'm going to do is very common when we're doing proofs. It is one of the more difficult parts of doing a proof, and even people that have taken the proofs courses in university still sometimes have difficulty determining this next step. It just really comes with practice. So what we're going to be doing is we're going to be introducing two new terms to this. These two new terms will add to nothing. So essentially we're adding nothing to this formula. So I'm going to keep what I have here. Sorry. F of x plus h times g of x plus h, all divided by h. I'm going to throw this f of x, g of x in here. And I'm going to go ahead and I'm going to add those two new terms right in the middle. Now you're going to be able to see what happens since I'm adding these two new terms in the next line. So basically, I've subtracted a term and added the exact same term. So I'm really adding nothing. But these two terms will allow me to do some common factoring and break it up into multiple terms so that I can reach this end goal that I have here. What I'm going to be doing in this next section is breaking this up into two separate terms. So as you can see in the line that I just wrote in, I've just broken it up into these two parts. It might be more obvious now with the information that I added, these two expressions that I added, why I added the negative first. Maybe when you're looking at this, you're seeing some similarities with first principles that we've talked about so much through all of these proofs and last chapter. At this point, I'm going to go ahead and I'm going to common factor what I can. So when I look at this first expression, I will be common factoring out an f of x plus h. And in the second, I will be common factoring out a g of x. So now that I've done my common factoring, I can really start to see that I've got some first principles going on here, at least part of the definition. So I'm going to be going ahead and I'm going to be breaking this up and adding the limits to both of the terms in each of these expressions. So at this point in time, I'm really sorry. I know it's squashed and really messy. I'm obviously running out of space. But what I'm going to do is I'm going to be plugging in my limit as h approaches 0, or applying that limit. And so when I'm doing this, I am getting rid of writing the limit. I'm no longer writing that. So if I have the limit as h approaches 0 of f of x plus h, all I'm left with is f of x. And what I can see in this expression, the limit as h approaches 0 of g of x plus h minus g of x all over h is my first principles, g prime of x, plus the limit as h approaches 0 of g of x. That is just g of x. There's no h in there at all. And this last, the limit as h approaches 0 of f of x plus h minus f of x all divided by h is f prime of x. So what I've been able to do is officially prove the product rule. Now, if you wanted to, just to make it look more like what we're used to, we can rewrite this so that this term is first. So f prime of x times g of x. F of x was our first function. So this is just tidying it up a little bit. Plus f of x times g prime of x.